If you've been around software development for a bit, you've definitely heard folks debate branching strategies. And you've for sure heard them talk about CI/CD pipelines. But a lot of times they're taught as these two totally separate things, right? Like they belong in completely different textbooks. Well, today, we're going to look at a fundamental truth here. Branching and CI/CD are absolutely not separate. They are one continuous system. You see, branching is really just how we humans divide and organize our work, while the CI/CD pipeline is exactly what the machine does with that work once it's merged together. It's literally the spot where human process seamlessly meets machine automation. Let's get right into it. Here is our quick roadmap for today. First, we'll look at the unified GitLab platform. Second, the 4 branch types. Third, the 5 pipeline stages. Fourth, the end-to-end flow. Fifth, the trunk-based reality. And finally, number 6, choosing your strategy. Okay, part 1, the unified GitLab platform. So before we jump into the pipelines, we've got to understand the platform ecosystem. At the end of the day, we're dealing with code, and we need a super secure, safe way to change that code, right? Enter the branch. Think of a branch as a parallel, isolated sandbox of your code base. It's a safe space where a developer can build a brand new feature or, try out some wild idea without any risk of breaking the stable, golden version of the software. That golden, production-ready version, we almost always call that the main branch. And if there is one golden rule of software delivery you take away today, it's this: main must always, always be stable. Now, what makes a platform like GitLab so incredibly powerful is that it brings 3 really critical components together natively. First up, you've got code hosting for version control. Second, you have code review through things called merge requests. And third, it houses your automated CI/CD pipelines. The whole point here is that all 3 of these things live right there in a single unified place. You aren't, duct taping a code repo to some third-party testing tool and a totally separate deployment server. It's one seamless ecosystem. That removes a massive amount of friction for developers and basically lets the whole system function as one continuous flow. Moving right along to part 2, the 4 branch types. All right, so we know where the code lives. Now let's talk about how humans divide the work up. This brings us to the 4 distinct branch types. I'm going to walk you through exactly what they are, what they do, and how they live and die. First up is the feature branch. The whole purpose of this branch is to develop new features and enhancements. A really concrete example you might see out in the wild is a branch literally named features/login. A developer reaches for this specific branch when they're building a brand new piece of functionality. At the end of its life, so after the code is thoroughly reviewed and tested, this branch is merged right back into the main branch. Next, we have the hotfix branch. Its purpose is to deploy urgent fixes to code that is already live in production. For example, you might see hotfix/issue 123. A developer grabs this branch when something is actively broken in production and it absolutely, positively cannot wait for the normal development cycle. At the end of its life, it gets merged back into main incredibly quickly, basically bypassing that standard, slower release schedule entirely. Third on the list is the release branch. The purpose here is preparing and stabilizing a specific version of your software for deployment. An example you'd see is release/v1.2. A team reaches for this branch when they're freezing new features and solely focusing on polishing up a specific milestone. At the end of its life, once that specific version successfully goes live, it's merged back into main just to ensure any final last-minute bug fixes actually make it back to the stable codebase. Finally, we've got the experiment branch. Its purpose is exactly what it sounds like, trying out completely new ideas or proof of concepts. An example might be something like experiment/AI. A developer reaches for this when they really just want to see if an idea is technically possible without actually committing to building the full feature. Now, what makes this branch totally different from the other 3 is its end of life. It might be merged into main, sure, but it also has the unique optionality to be entirely discarded and deleted if the experiment just flat out fails. And that brings us to the ultimate governing rule of this entire human process. If you look at how the feature, hotfix, release, and experiment branches flow, they all eventually point right back to that stable baseline. Every single branch merges back to the main branch, and the main branch always stays stable. That is the cardinal rule of this whole shebang. All right, let's switch gears to part 3, the 5 pipeline stages. Okay, so the humans have successfully written and merged their code. Now let's hand it over to the machine side of the system and see what happens next. This is your CI/CD pipeline, which stands for continuous integration and continuous deployment. We can break this down into 5 really clear stages, and honestly, it's pretty fascinating to see what each one actually accomplishes. Let's walk through them in order. Stage 1 is pull. The machine fetches the latest, freshly merged code right from the repository. What the team gets out of this is the absolute guarantee that the machine is working with the most up-to-date version. Stage 2 is compile, or build. The machine turns that human-readable source code into executable artifacts. The team gets a runnable version of their application. Stage 3 is test. The machine runs automated unit integration and security tests. The team gets the confidence that their shiny new code didn't break anything old. Stage 4 is deploy. The machine pushes the application to a staging or production environment. The team gets their actual software in front of real users. And finally, stage 5 is monitor. The machine collects application metrics, logs, and alerts. Here, the team gets vital, real-time visibility into the health and performance of their live application. Now, there is a very strict law governing this automated machine, and it's known as the fail-fast rule. To put it plainly, if any stage fails, let's say a test fails in stage 3, or maybe a build fails in stage 2, the entire pipeline stops in its tracks and notifies the team immediately. It does not proceed. No exceptions. This rule is exactly how the system guarantees that broken code never, ever reaches your production environment. You know, it's really easy to look at diagrams with pretty cloud icons and little gear wheels and think this is all just machine magic. But in practice, these 5 stages are defined by something super concrete, a YAML configuration file. This is literally just a simple text file that lives right inside your project repository alongside your code. A human developer actually writes and maintains this file to explicitly tell the machine what scripts to run for the build, test, and deploy stages. So, at the end of the day, even the machine side is ultimately steered by human instruction. Which leads us perfectly into part 4, the end-to-end flow. So, we've looked at the human branching workflow, and we've explored the machine pipeline workflow. Let's see how these two halves actually connect to form one single continuous delivery machine. Tracing the step-by-step flow here. Step 1 is hosting the code. Step 2, a human creates a branch. Step 3, they develop and test locally. Step 4, code review and approval. Step 5, the human merges the code into main. Now, the absolutely crucial point here is step 6. Step 6 is the seam. It's the exact moment the human process ends and hands off to automation. The human clicks merge, and instantly, step 7 takes over. The pipeline pulls, builds, tests, and deploys the code without any further human intervention. That single click unites the two worlds. Let's move on to part 5, the trunk-based reality. Now, I gotta level with you. The tidy 4-branch model we learned a few minutes ago is really great for beginners, but in the real world of high-performing software teams, it introduces a pretty critical tension. That beginner model kind of implies that branches are a comfortable place for code to live for days or even weeks. But elite research, like the data from DORA, the DevOps Research and Assessment Team, shows the exact opposite. Effective real-world development, which is known as trunk-based development, means a team has fewer than 3 active branches at any given time, and those branches have a lifetime of less than a single day. The research paints a really clear picture here. Long-lived branches force larger, riskier merges. They require long stabilization periods and painful code freezes where everyone just has to stop working to untangle conflicts. On the flip side, trunk-based development is treated as a mandatory practice for true continuous integration. When you merge code daily, your merges are tiny, fast, and incredibly low risk. The core takeaway here is that the metric that actually predicts your team's delivery performance is not which of those 4 branch types you picked. It's how long that branch stays unmerged. And finally, part 6, choosing your strategy. So how do you actually apply this to your own work? Well, a lot of teams find a pragmatic middle path called GitLab Flow. This strategy basically uses main as the default from day one. All features and hotfixes go straight into main, but they layer on pre-production and production environment branches. That means promoting code to production happens simply by merging from main. But to figure out exactly which strategy is right for you, you need to ask yourself 3 diagnostic questions. Number 1, what is your release cadence? Do you deploy multiple times a day, or do you have strict scheduled monthly versions? 2, what is your team's size and seniority? 5 senior engineers can manage a very different flow than 50 junior engineers. And 3, how many production versions do you support at once? If you only have 1 live web app, your strategy should be vastly simpler than a team supporting 3 different historical versions of some massive enterprise software package. I want to leave you with a final, somewhat provocative thought to help you evaluate your own workflows. A team with sloppy branch names that merges their code into main every single day will consistently deliver software faster and more safely than a team with perfect, beautiful branch names whose code sits in isolation for a week. Remember, branching is really just a temporary human division of labor. The actual goal is getting that code to the machine pipeline as fast as possible. So think about your own branches today. How long have they been sitting unmerged?